Okay, so this is the first of my video logs. I'm at uni at the moment, a little bit bored, so I thought I'd get this rolling. I've always wanted to start to make some video logs just about science in general, just more for my teaching really. So this one, we're all made of stars, just as Moby said, we're all made of stars. Even do a little star there for you, just so you know what a star is. So basically, yes, we are all made of stars. Obviously everyone knows that the creation of the universe started with the Big Bang, but then if it wasn't for what the Big Bang created, which was stars, and the process of stars then exploding, supernova, then basically we wouldn't be here. Obviously there's a lot of other processes, but this is basically just in terms of the elements and the atoms of your body and everything else, and where they were actually created and how. So we'll go from here. Okay, so most people know what the Big Bang is, but for those that don't, I'll just give a quick rundown. So, when the Big Bang started, okay, so it was smaller than an atom. We all know how small atoms are. It's the smallest thing, well, one of the smallest things we can imagine, apart from subatomic particles. But yeah, we can't even see it, so you know how small that is. So basically started at a point, there was a little bit of interaction there, just boom, exploded, okay? We can't even fathom how fast and how far it exploded. It's basically, the Big Bang is what is creating space. So at the moment, the universe is still expanding, it's actually accelerating, it's getting quicker. Soon they won't, well not soon, but relatively soon in terms of the universe, it'll actually be expanding faster than light. Now nothing is faster than light, but what that means is that the space that's created from the expansion is moving faster than the speed of light. So there's more space being created, even though that's not being quicker than the speed of light. It's just that the light can't actually reach you because there's too much space in between being constantly created. Okay? So, Big Bang, in terms of elements, okay? When that first happened, massive amounts of heat and energy, okay? And as soon as that happened, the universe started to cool down, okay? So it was massively hot to start off with. It's down to about 3 degrees Kelvin, which basically means you have the absolute zero. So we think 0 degrees Celsius is zero. Obviously it's not, because you get minus degrees. Basically minus 273.15 degrees Celsius, to be exact, is absolute zero. You can't go below that, okay? So we're actually 3 degrees above that at the moment, which means it's about 270 degrees, minus 270 degrees. So that's where we're at in terms of the universe as a whole. It's a very cold place, the universe. So when it first started, very hot, okay? Started to cool straight away as it was expanding, and the first things it created was hydrogen. Okay, that's number 1 on the periodic table of elements. So from there, basically, if you forgot your chemistry from high school, so you've got hydrogen, which is an atom of 1 proton, 1 neutron, and then 1 electron on the outside. Okay, so the proton determines determines the number of the order of the element. So basically, that's 1. Okay, so from there you can only go up to 2, which is helium. Okay, so now you've got 2 electrons, 2 protons, and 2 neutrons. Okay, just keeps going up like that. Okay, so from there, this is all in the Big Bang as well. Okay. So this is what this created. So this didn't create all the elements, as you'll see. This only created the first 3. The Big Bang only created the first 3 elements on the periodic table. Okay, and it's only a very small amount of lithium. It's actually a lot of hydrogen. It's around 80% the universe in terms of the elements. Hydrogen, obviously, because number 1, it's the easiest to make. Okay, so from the Big Bang, so that's the Big Bang nucleosynthesis, which just means that's how it made those particular atoms. Okay. Or those elements, I should say, because you can have multiple atoms, but of only particular elements. So from there, we go on to the subject of this whole thing, stars. So, stars, okay? Basically, stars first formed, I think they said it was about 100 million years after the Big Bang. So it was quite a long time until that actually happened. And what happened there is the hydrogen actually formed from, obviously everyone knows about gravity. So gravity puts pressure and they coalesced all this hydrogen. Obviously a hydrogen has mass. So it coalesced and then basically formed so much that it went on to create so much heat and energy that it then fused these hydrogen atoms to go into helium. So it went from, as I put up before, from one proton and one electron to two protons and two electrons. So from there we can see how stars started to process. So hydrogen gas compressing together to form these other elements, helium. We actually found helium for the first time was actually on our sun, which is a star. We didn't find it on our Earth until that time. And we actually detected it in the sun. That's why it's called Helios, or helium. Actually, it's a bit of a misconception there as well. If you have Em at the end, as you'll see with a lot of elements, like magnesium, usually means it's a metal. Obviously, we know helium isn't a metal, it's a gas. So there's a little bit of a problem there. But everyone should know, just think of balloons, helium, gas. Okay, so stars. The hydrogen compressed to go into the helium. Then, what actually happens in stars, depending on the size, okay, so the bigger they are, obviously means they have more mass, more gravity, more compression, okay, towards the inside, in the middle. So, they can keep going up in numbers, okay, in terms of making these atoms. And what stars can actually do, the most massive stars, can actually go from hydrogen all the way through to iron. Okay, so that's everything in between there. So oxygen, nitrogen, carbon, they're actually the things that make us, which are actually low numbers, which shows that we aren't actually made of the rare stuff. We're actually made of pretty common things. Hydrogen as well, so hydrogen, oxygen, water. So from there we have to iron. But what about the other elements? Okay, we've heard of other elements that go a lot higher than iron. One of those being gold, for example. We all like gold. So it goes up here. The way we actually get those elements is if a star is massive enough, okay, it's gone up to iron, it's used up all its hydrogen, okay, so the hydrogen is all gone, it's all fused up. So what then happens, it all radiates off, and then it starts to collapse in on itself because of the gravity. Obviously, it's getting more mass because it keeps fusing these together. Okay, creating more mass. Obviously, there is more gravity there as well, so the gravity is compressing in on it. And basically, what then happens if a star is big enough, it'll go supernova. Okay, so if a star goes supernova, then that means that the amount of gravity compressing in on it is basically too much. It's the amount of heat and energy inside of that is what causes it to explode. So it collapses and then it has too much and then boom, straight out. So what actually happens there is it creates all the elements up to uranium. Okay, so obviously there's higher elements than uranium, but they're actually synthesized in the lab. So they don't usually last long and they only get synthesized from particular techniques in the lab. But in terms of natural, what you call natural elements, it goes up to uranium. So basically here, as you can see, all the elements, starting with the Big Bang, the stars then use the hydrogen to keep fusing, to keep going up to the higher elements, all the way up to uranium. Okay? So our sun, at the moment, it's not a big star by any means. So what will actually happen with our star is basically it will continue to expand, continue to form hydrogen into helium, keep fusing those. It'll go into a red giant, red supergiant they call it. It'll take out our planet, and basically our star is a good a lifetime of about 10 billion years. So we're 5 billion years through that. The Earth is 4.5 billion years old. So our Earth didn't form too long after the star. So at 10 billion years, you'll see basically, we won't see it, but others could. It'll collapse in on itself, but because it isn't big enough, it won't actually go supernova, it won't explode. It'll just crush in on itself and it'll form what's called a white dwarf star. Okay, there's plenty of those out in the universe, we've seen a lot of them. And yeah, that's basically what happens to it. So from there, we can basically see, okay, so elements, okay, stars. We're all made of stars. You can have one hand, pick an atom out of one hand, pick an atom out of your other hand. They can be from completely different stars, okay? Everything in our solar system, okay, those atoms, some of them are actually created here, like in the sun, you get helium from the hydrogen, okay, but that hydrogen originated in stars billions of years ago, and they had gone supernova, they were big enough to go supernova, and they've just spewed all their atoms all the way up to uranium into the universe, and then because of gravity again, it's actually picked up a lot of that and collapsed in on itself. That's why you see all the planets, they're all circle, okay, because that's the gravity, it pulls on every direction, okay, so it pulls in, you've got sphere-like structures everywhere, you've got a sun which is massive compared to the planets, okay, so that's why the planets are circling around the sun, because the sun's gravity is too much for everything else. I mean, even just in terms of gravity, just for a little bit of reflection, it's basically, if you've got Jupiter, okay, which is the biggest planet in our solar system, the gravity of that, okay, so if something is falling towards it, because don't forget, in space there's no up and down, it's just everything is falling, okay, but it's attracted to other masses, okay, so you've got Jupiter, which is quite a big mass, that actually can reflect a lot of things, a lot more than, say, Earth could. So when an asteroid passes Earth, okay, our gravitational pull will swing it around, okay, but only very slightly, because we're not very big at all, okay. Whereas if you have Jupiter, which is a lot bigger, okay, that'll actually curve it more. It'll actually curve it around, and it could direct it into our path, or it could direct it away from us, okay. So Jupiter could help us, or, you know, if it thinks we don't really like Earth anymore, bang, just like it did 65 million years ago with the dinosaurs. So, well, it wasn't Jupiter's fault, or could have been, but, you know, we know that an asteroid hit 65 million years ago, wiped out the dinosaurs, apart from the birds. Birds are dinosaurs. Without scales, they have feathers, just in case you didn't know. So, as we can see, okay, I don't think I need to explain it any further, that stars are what exploded, okay? So you can think of it, you have your little section on your windows if you want, I don't care. Okay, so it exploded, okay? Which then went on to create the atoms that make us. Everything else that you can see around you, unless you're a lab technician and you can make your own atoms yourself, then basically everything has come from a star, a different star in the universe, okay? Just a little point as well for those that may be interested, otherwise you can switch off now, but stay, I'd like you to stay. Basically, there's an interesting point about why our universe is expanding and accelerating, okay? So the reason why, and there's a lot of study going on to this now, the reason why our universe is expanding, so basically, as I've been talking about gravity, you think, okay, hang on, so everything's attracted to one another, okay? There's no up and down, they're falling constantly. So our moon, okay, so we've got Earth, the moon is constantly falling, we just keep kind of picking it up, okay? There's no up and down, it doesn't matter which way it goes, that's the way it works, okay? So, if you think, okay, Big Bang exploded, has so much energy and power that it's obviously going very quickly, okay? But you think, hang on, it's going to start to slow down because of that gravity, of all that mass inside the universe. So they had it. That's what they were thinking for quite a long time. Okay, so for quite a long time we thought that the universe had no beginning or end, and it was just as it was, as it is, and always will be that. But Edwin Hubble found out that it wasn't. That's basically he did that by looking at the stars, and he noticed that they were in a slightly redshift, which means that they are going away. If something's blue, okay, obviously we can't see it like that, but you can use certain techniques and instruments to actually see if they're slightly blue or slightly red. If a car was coming towards you, okay, it would be slightly blue if you had the right technique to do it, the right technology. When it's going away, okay, it's actually red, okay, and you actually can tell that with sound as well. You know the difference between a car's coming towards you and when it's going away from you. It's a different sound. It means it's stretching those sound waves. Just like light, okay? Light actually stretches those waves. It still travels at the same speed, but it actually stretches. Or it contracts, okay? So if it's contracting, it means something's coming towards you. Contracting it like an accordion, okay? So that would be blue shift. But it's actually what Edwin Hubble found with his telescope. You probably heard of the Hubble telescope, that was named after him, obviously. Is that it's actually, they're stretching, it's red. Okay, so that means that the universe is expanding. Everything around us is expanding. Okay? And everything around everything else is expanding as well. That's an important point. We're not at the center and everything else is expanding around us. It's kind of like drawing dots on a balloon and blowing up. They all travel at different speeds from one another. It looks like you're at the center, but you're not. Okay, they're all traveling away from each other. Okay, so back to what I was going to talk about with the expansion of the universe. So at a particular point, I think it was about 7 billion years, okay, so our universe is, I think it's up to 13.72 billion years. They've worked it out more precisely now. I think, so around 7 billion years after the universe, after the Big Bang, what actually happened was the gravity wasn't strong enough. Well, it was strong, but it wasn't strong enough to what actually happened is that the space, okay, so people think of empty space as nothing, there's nothing there. What they've actually found is that empty space actually has energy. It's called dark energy, okay, you've probably heard of it. So dark energy, we don't really know what it is, we just know it's energy, okay. The reason why we know that is because as the universe has been expanding, basically the amount of space that's there, and because obviously it started to slow down, you had to have energy for it to still be expanding. Otherwise, what would happen? It would come out, it would come straight back in because of the gravity. Okay, and it will collapse in back on itself. Okay, so what actually happened was it went out. It was with the universe, as I was saying. When you the Big Bang was created space. Okay, space wasn't there before. It actually created space. What we think of as nothing. Okay, just empty space. So what happened is, because obviously as it's expanding, it's creating more empty space. That's creating more dark energy. That energy is repulsive, so it's pushing it out. Okay, so it got to a certain point. The gravity was very strong. It was slowing it down. Now what's happening is that there's a lot of dark energy. There's a lot of space. The universe is getting bigger. So it got to a certain point, and now it's accelerating at the moment. So it's going to keep on accelerating because obviously it got to that certain threshold point. It's going to still go, and it's going to keep accelerating because there's going to be more dark energy. And basically, it's our universe, as I was saying before, we're at 3 degrees Kelvin. We're going to end up at 0 degrees Kelvin because it's just going to keep cooling. Gradually and gradually the stars are going to burn out. They're going to die out. They're going to use up all their hydrogen. And really there's nothing we can do about that. I don't know the exact time frame. Don't have to worry about it just yet. But basically that's what's going to happen. Everything's going to die out. There's going to be black holes, white dwarf stars, everything else. And eventually they're going to go as well. It's just going to be complete nothingness but that dark energy, and that's just going to keep expanding and keep expanding. Just can keep going. Keep creating space, keep creating dark energy, and that's pretty much it, even though there's going to be nothing left inside, basically. So yeah, that's our future, or our ancestors' future, the human race, if we don't die out before that. So yeah, I hope you enjoyed that. Went a little bit over time, but you know, it's science. I love science. I hope you do too. So thank you for watching and listening.